let's talk about half-lives, because it is exactly kind of what it sounds like. It's the time it takes for the amount of substance to fall to half its initial value. So if you look at this chart here, you can see at the very beginning, the items fall rapidly because half of 100 is 50, half of 50 is 75. So it rapidly decreases, but it falls in half of the amount of a substance. So as there's more half-lives, items fall to smaller amounts. Half of 15 is 7.5, half of 7.5 is 3.25, half of 3.25 is 1.125. I think the smaller numbers I start to need a calculator, but it will still take 57,000 years to be less than the original 0.1%, because you start to get half of a half, half of a half, half of a half. So despite the fact that it falls sharply at the beginning, it still takes a really long time for items to completely dissipate, because you're just taking half of whatever amount is there. Okay, so let's talk about the half-life formula. The one that we use. There's tons of half-life formulas out there, and I'm going to give you a different formula at the end, depending on how you want to approach the problems. But the best way that I think of doing it, the better way, is number of half-lives equals total time divided by half-life time, because we are always given about 2 of these items, or the ability to find 2 of these items, so we can always find the third. So let's look at it a different way. We're going to use an equation triangle. I really like equation triangles because it allows you to completely manipulate the equation by just remembering the triangle. So this is the half-life formula triangle. Total time is on top, and then you do like a T to split the triangle into 3 parts. Number of half-lives is down on the left, and half-life time is on the right. And what you end up doing is, if you cover what you're looking for, and you'll be left with the formula. So if you cover up total time, you're left with number of half-lives times half-life time. That is the formula for total time. If you're looking for number of half-lives, you cover that up, and you're left with total time divided by half-life time. That's your formula for number of half-lives. If you're looking for half-life time, you cover that up, and you end up with total time over half-life, number of half-lives, and that's your formula. By using the half-life formula triangle, it really helps if you can just remember the triangle, so that you don't have to remember how to manipulate the formula every single time. Okay, so let's walk through a sample half-life problem. So a problem might be the half-life of zinc 71 is 2.4 minutes. If one had 100 grams at the beginning, how many grams would be left after 7.2 minutes have elapsed? So the first step you're always going to do is outline the information provided. So when we pull that information from the word problem. So reading along, we have a half-life of 2.4 minutes. So our half-life time is 2.4 minutes. We want to know how much would be left after 7.2 minutes. So we have total time of 7.2 minutes. Then we were given a starting amount of substance. That's 100 grams. And it's really important, if it says starting or ending or starting or remaining, to label that very clearly, because that gives you different types of information. So let's talk about now step 2. Step 2 says you're going to determine missing information. So what are we looking for? We are looking for the ending amount. We know that because it asks how many grams would be left. Left would mean the remainder. It might say how many grams remain. All that means is ending amount. How much is left? And then we also need, from the half-life formula, the number of half-lives. There will almost always be something from this formula that needs to be solved. may not always be solved in this order, but something will always need to be solved. Now we're going to find the missing information from the half-life formula, if you can. This is the step 3 for this problem specifically. So we were given number of half-lives, which was, to remember, number of half-lives is total time divided by half-life time. Our total time was 7.2 minutes. Our half-life time was 2.4 minutes. You get this information from step 1 where you've outlined your information. So we end up with 7.2 divided by 2.4 gives you 3 half-lives. What you could also do is, what you could do is plug it into your half-life equation triangle with your total time on top and your half-life time here. It leaves you the formula and you were able to complete the triangle with 3 half-lives. Okay, now let's do the next part of the problem. We are looking for how much is left after 3 half-lives. So there's 2 ways of doing this. I'm going to show you the chart way, and then I'm going to show you the exponent way. I don't care which way you use, just make sure that you're able to do both ways thoroughly, or choose the way you want to do and be able to do it really, really, really well, because half-lives, you're going to have to do all this kind of manipulation. So I always do the chart. Remember, you always start at 0 half-lives, because this is the amount of time before you did anything in half. So at 100 grams, you did not even have 1 half-life. So that's your 0 half-life. At 1 half-life, 2 half-lives, and 3 half-lives, how did I put 1, 2, 3 down here? Because on step 3, we figured out we'd had 3 half-lives. So we want to know how much would remain after 7.2 minutes. That was 3 half-lives. So now we just divide in half for each half-life. So 100 divided by 2 is 50. That's my first half-life. 50 divided by 2 is 25. 25 divided by 2 is 12.5 grams. That is my third half-life. You're going down the chart, you're going to divide the amount of substance by 2 for each half-life if you're solving for either a remaining or ending amount. So 12.5 grams is my final answer for this problem. Okay, let's try another problem. Carbon 15 has a half-life of 2.449 seconds. That means that every 2.449 seconds, half the amount of the substance dissipates or transforms into a different carbon. That's sometimes what happens with half-lives. If you end with 3.75 grams of carbon 15, how much did you start with if 7.34 seconds have elapsed? So step 1 will always be to outline the information provided. So reading from the word problem, our half-life time is 2.449 seconds. So my half-life time is 2.449 seconds. Outline everything you can. We were given a time of 7.347 seconds as our total time, so we can label that. It's always good if you label your times together and if you keep the same labels so that you are always following along. Then we were provided an ending amount of the substance. That's 3.75 grams. That's my ending amount. So you just can't put amount of substance. You need to put ending or remaining. Those two are the same. And then you have to, or put starting, because ending and starting are different placements and different meanings. So you need to make sure you're really clearly labeling them. Moving forward. So if step 1 was to outline all the information we were given, step 2 is to determine the missing information. So I always look to my half-life formula to see what is missing. We are missing the number of half-lives. Please remember, we are always going to solve something from this formula, almost always. And we also need to find the starting amount of the substance. These are the 2 things we need to solve for this problem. So step 3 for this one, and remember step 3 and 4 may be switched depending on the problem, is to find the missing information from the half-life formula. You either need to figure out how many half-lives there are at the beginning or at the end. That's almost always what we're going to have to be figuring out. If you're given beginning and ending amounts, you'll find the half-lives later. If you were given either the beginning or ending amounts, you're probably going to have to find number of half-lives first. So number of half-lives equals total time divided by half-life time. So when we get this information from your step 1. So step 1, we labeled our total time as 7.347 seconds. Step 2, we labeled our half-life time as 2.449 seconds. So we ended up with 3 half-lives. You also could have plugged them into your half-life triangle and solved it the same way. Okay. So then step 4, remember, you either have to find the number of half-lives, or what's missing from the half-life formula, or the amount first. Depends on how you're doing it. So for this one, we had to find number of half-lives first so we could set up our half-life chart, our T-chart. So remember I said it was important determining if you were given a remainder or a beginning. So we were told remaining. So we had, remember you always had to include the 0 half-life. So 0, 1, 2, 3. 3 is remaining. So you put that at the bottom. So when you're going up the chart, you're going up the chart, you're multiplying by 2. So 3.75 times 2 is 7.5. 7.5 times 2 is 15. 15 times 2 is 30. So our missing amount, our beginning amount would be 30 grams. And yes, I know this randomly changed to the other problem, and I apologize. So there's another way of doing it. I don't really like to teach this way because it just adds an additional amount of math that you don't need to do. But if you don't like the T-chart, and I had a lot of students say, but we learned it a different way in math, here's a different way. For finding the remainder, given half-lives and starting amount, you can do 0.5 to the exponent, that is number of half-lives, gives you the decimal of the amount remaining. You take the amount remaining, the decimal of the amount remaining, and multiply it by your original amount, you get your amount remaining. So it's a 2-step. It's a similar amount of math, but it's a different kind of math. I'll pause here if you want to write this down. You are not required to do it this way.